Hello, it's Brian again. Today we're going to be looking at correlation and some basic, or I'll call it simple linear regression in StatCrunch. So when we're talking about correlation, we're looking at a linear relationship between two variables. So when one of the variables tends to be higher, the other one either tends to be higher or tends to be lower, right? That an increase in one variable is associated with an either across the board, it's usually associated with an increase in the other variable or a decrease in the other variable. And those are referred to as a positive linear relationship and a negative linear relationship. So anyway, we're going to measure this with what's called the correlation coefficient, which is another statistic that can be calculated. Here's an example. A pediatrician wants to determine the relation that may exist between a child's head and the head circumference. The child's height and the head circumference. She randomly selects 8 children, measures their height and head circumference, and obtains the data in the table shown. So here's the table. So if the pediatrician wants to use height to predict head circumference, height is known as the predictor is also known as the explanatory variable. And the response variable is what we're trying to predict. So we're trying to predict head circumference. Head circumference is the response variable. The explanatory variable is height. All right. Now let's actually go to StatCrunch for the rest of this. Let's take our table and let's click open it in StatCrunch. All right, so we have our data here. I'm just going to briefly move it now. The first thing we want to do is to create a scatter plot of the data. Scatter plots are easily made under the graph menu. We go down to scatter plot. Simple enough. The x variable we want to be the explanatory variable, which in this case is height. And the y variable is the response variable. That's going to be head circumference. Okay, I'm just going to click compute and see what this looks like. We may want to play with the options, but the basic scatter plot might be perfectly fine for what we're doing. This looks good. It looks like we've got our you can see the height in inches down below. We have this nice little pattern. I'm looking over at the choices. So let's just check. You see we have height on the x-axis, circumference on the y-axis. We can just double check. This looks good. We have the same units everywhere. Choice A is the correct answer. All right, we're going to compute the linear correlation coefficient. Let's go back to StatCrunch, and I'm going to close this. The correlation coefficient is easily calculatable. We don't have to deal with any formulas. We're going to go to, so we go under Summary Stats and go to Correlation. We're simply going to pick both of these, so I'm going to hold down Shift while I click both of them. Those are the two variables. Let's see. Let's display the two-sided p-value. I'm going to just click compute and see what we get. Okay, so this gives us our correlation coefficient, 0.9371. 0.937, 3 decimal places. Now, does a linear relationship exist? To answer this question, we have to ask, is this correlation strong enough for this size of a sample? We have a sample size of 8, and so we have to look at the critical values for a correlation coefficient. You can see this table. If I click that, I'm going to get this very simple table. It just says, for any given sample size, how strong does the correlation coefficient need to be in order for me to claim there is a significant correlation between the two. So it says for a sample size of 8 that I need a correlation to be either greater than 0.707 or less than negative 0.707. So this is saying in absolute value terms, the correlation coefficient must be at least this big. And it is, right? We have 0.93 and it is. So we say yes. There appears to be a positive linear association between because R is positive, yes, and it's greater than the critical value. That's choice A. It's greater than the critical value.